Distance is the total amount of area travelled or covered by a person or object. It is a scalar quantity as it only has magnitude. An example of distance is if a basketballer travels 7 meters from the center circle to the basket. Displacement is the distance between the starting position of an object or person and then the finishing position of that same object or person. For instance, if the ball travels 5 meters to the backboard and bounces off it and travels 5 meters back to the same place where a defender has collected the rebound, then the displacement is 0 because 5 take away 5 equals 0. Displacement is a vector quantity because it has magnitude for 5 meters and direction, so north and south, to and from the backboard. Acceleration is the rate at which the body or an object changes velocity. Acceleration is a vector quantity as it has both magnitude and direction. For example, if a basketballer is sprinting with the ball down to the opposite hoop, then this is acceleration, as they are increasing and changing their velocity, which is speed in a given direction. As they started off static, and then there is a sudden burst of speed, so they are accelerating. They also can decelerate, so this means their velocity has a negative change, resulting in the athlete slowing down. An example of this is when the basketballer gets to the hoop that they are shooting in. They need to slow down to stop in some cases, as they need to set their body upright in the correct position to take a shot like a three-pointer, and they can't do this when their body is still accelerating. Your centre of mass is the point at which you or an object is balanced in all directions. Stability links with the centre of mass because when completing certain movements, your centre of mass changes depending on how you move, which is the same as your stability. Increasing your stability will prevent movement from occurring. For example, a wider base when blocking someone out in basketball prevents you from falling over when your opponent is trying to get past you, because you are stronger with a wider base as you are more stable. However, being unstable increases movement. Referring back to your stance, if your base isn't wide, then you are more likely to get pushed over, as your distribution of mass is not spread out, so you therefore become unstable. In contrast, being unstable can help create movements, as you only become unstable if your line of gravity is outside the base of support. For instance, at the beginning of the rotation phase in a cartwheel, your body needs to be unstable in order to create the rotation movement. A force is a push or pull motion to alter the state of motion of an object. You can change the state of an object in 5 main different ways when using forces. You can simply change an object from a resting state to a moving state. You can do this by rolling or bouncing a basketball that is stationary on the sideline. You can change the direction of something by applying more force against that object in a given direction. An example of this is when the athlete throws the ball up against the backboard, then the ball pings back in a different direction. You can also change the shape of an object by applying force. For example, if a player bounces the ball on the ground, the part of the ball that meets the ground momentarily flattens, therefore changing the shape of the ball before it bounces back up to the player. Acceleration changes something or someone's velocity. Therefore, if a player is stationary when collecting the ball from underneath the basket, then picks up speed when running down the court, that is acceleration. On the other hand, deceleration also can change something or someone's velocity, as this links with acceleration. If the player that is running down the court spots another teammate, they will decelerate, so will slow down, so that they can give an accurate pass. Inertia is the reluctance to change, and the inertia on an object increases depending on the magnitude of the object, as a much greater force is needed to change that inertia. The first of Newton's laws state that unless a greater force acts upon the object, then it will stay stationary or keep moving at the same velocity. If we apply this law to basketball, then when the ball is stationary on court and the player, so the external force, will change the inertia of the ball by rolling it across the court to his or her teammate. The net force is the overall force acting upon that object in a given direction. The second of Newton's laws states that acceleration is proportional to the force that is acting upon the chosen object, and it happens in the direction the force acts on the object. Mass will affect acceleration. For instance, the greater the mass of the object, then it will need a greater force acting upon it to change its state. An example of this is when passing the ball, you need to apply a greater force than the mass of the ball to get it to travel to your teammate. Newton's third law states that for every action there is an equal and opposite reaction. So in basketball, when bouncing the ball, the action is the ball going down and the reaction is the ball bouncing back up. The reason why the ball moves when you apply force to it is because it is a smaller mass, so it moves and you don't. The impulse upon an object is the same as the change of momentum on that object. To change the impulse, you have to change the time taken for you to release the object, or the size of force you apply to the given object, or both. An example of this is a slam dunk in basketball. If you increase the time taken for the ball to go down into the hoop, then you increase the impulse and consequently increase the momentum of the ball.